All right, we're on the last part of B2. In this portion of the videos, we're going to go ahead and talk about features of the quadratic formula, and we're going to focus on something called the discriminant. Okay, so let's start with features of the quadratic formula. So some of these we know. The first thing that we have is everything outside of our quadratic formula. And so let's go ahead and review what we're talking about here. Our quadratic formula, remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you recall, we've looked at finding the vertex, and when we're in standard form, remember that the vertex is given by the stuff outside the square root. This gives us the x-coordinate of the vertex. Now, the inside of the square root also tells us something about our quadratic function. And so the b squared minus 4ac, we call this the discriminant. And so what does this tell us? Well, depending on whether this is positive, negative, or 0, it tells us how many real solutions we have. The first one we're going to look at is if the discriminant is negative. If the discriminant is negative, there are no real solutions. And why is that? We cannot take square roots of negatives in the real number system. And so if we have no real solutions, then we also have that the graph has no x-intercepts. The second option we have is if the discriminant is 0. If the discriminant is 0, then there is only one real solution. And the reason is okay, well, what's the square root of 0? It is 0. And what we basically have in this case is we have negative b plus or minus 0 over 2a. And well, negative b plus 0 and negative b minus 0, these are the same thing. And so we have just one solution. Graphically, what this means is we have one x-intercept. And this x-intercept is the vertex of our graph. And so visually what we're looking at here is something like this. We have one point of intersection on the x-axis, and it's also the vertex. The last one that we have is if the discriminant is positive. And if the discriminant is positive, then we have two real solutions. We have negative b plus a number. We have negative b minus a number, and these are going to be different numbers. And then we divide by 2a, and we get two solutions. We can also go ahead and separate this into two categories as well. And the first one is, if the discriminant is a perfect square, then you can simplify it, and our solutions are going to be rational numbers. They're going to be integers, they're going to be fractions, they're going to be nice numbers. If it is a perfect square, then you can solve this using factoring. If the discriminant is not a perfect square, then we have irrational solutions. We get things like negative 5 plus or minus the square root of 7. These are still real numbers, they just are not nice real numbers. If they are irrational, then the equation cannot be solved using factoring. We would have to do completing the square or quadratic formula. The other thing that we have in this case is the graph has two x-intercepts. For both of these, whether they're real, whether they're rational or irrational, we should have two x-intercepts. Okay, so let's review what does this look like visually. So again, if we have the discriminant is negative, we have no x-intercepts, which means that when we look at our graph, it's either going to be opening up and above the x-axis. It can also be opening down and below the x-axis. Again, we have no x-intercepts. When it's equal to 0, we have one x-intercept, and remember that this is going to be our vertex. And the last one we have is when it's positive, we have two x-intercepts, and it's going to look something like this. Right, so now we're going to start with some equations. We just want to go ahead and talk about finding the discriminant to determine the number of real solutions. If the solutions are real, we want to choose and apply the best technique to solve the equation. All right, so let's go ahead and start with example A. Okay, we want to figure out b squared minus 4ac. And so just like when we do quadratic formula, we're going to plug in our coefficients. We get negative 12 squared minus 4 times 4 times 9. All right, negative 12 squared is 144. And if we multiply 4 times 9, we should also get 144. And we get this is equal to 0. So remember that we have, for our general rule, negative equals 0 real solution, 0 equals 1 real solution, and positive equals 2 real solutions. And so what we have here is we have 1 real solution. It is also going to be rational, and so this can be solved using any technique that we want. We can solve using factoring, we can solve using quadratic formula, we can solve using completing the square. I'm going to go with factoring because, as I said, I like to factor whenever I can. And so when we factor this, basically, I need my factors to be exactly the same. So 4x squared breaks down to 2x and 2x. 9 breaks down to 3 and 3. And I know my middle sign is negative. You can check this, but this is how it factors. The next thing that we want to do is we want to go ahead and set each factor equal to 0. And because they are the same, we only have to do this once. And if we go ahead and add 3 to both sides, divide by 2, we get x equals 3/2 is our solution. All right, let's come over to example B. All right, B, let's go ahead and find our discriminant. So we get b squared minus 4ac. We get a is 6, b is 1, and c is negative 2. And so if we plug in, we get 1 squared minus 4 times 6 times -2. And if we simplify this, we get 1 plus, I believe this comes out to 48. This is equal to 49. And so again, because we get a positive number, this is 2 real solutions. Because it is a perfect square, we can even go further than that. These are going to be 2 rational solutions. For this one, okay, what do we want to use in order to solve it? You could do factoring. You could also do quadratic formula. I would not pick completing the square on this because we do have that leading coefficient is 6. This number is a 1, and so completing the square may not be the technique that we want to use. So let's go ahead and I'm going to go ahead and factor on this one as well because I can. And so if we factor this, for 6x squared, I'm going to try 3x and x. 3x and 2x. The only things that multiply to 2 is 1 and 2. And in order to subtract to 1, I'm going to put my 2 in the first set and my 1 in the second set. When we do this, we get 3x and 4x. That does subtract to 1. We do want to subtract to 1 because we do have different signs. And in order to get a positive, I want my larger quantity, my 4, to be positive, and I want my 3 to be negative. All right, so now we can go ahead and set each factor equal to 0. In the first one, we can subtract 2. We can divide by 3, and we get x equals -2 over 3. In the second one, we can add 1 to both sides. We can divide by 2, and we get 1/2. And those are our 2 solutions. Okay, let's go ahead and come down to example C. All right, discriminant. We have A is 3, B is -1, and C is -1. And so when we plug in, we get -1 squared minus 4 times 3 times -1. And if we simplify this, we get 1 plus 12, which is equal to 13. It is positive, which means 2 real solutions. But here they are going to be irrational because remember this is inside the square root. Square root of 13 cannot be simplified. And so this cannot be solved using factoring. We have to do completing the square or quadratic formula. Again, I don't want to do completing the square on this one because we do have this leading coefficient. We also have this 1 in the middle, and it's going to get kind of hairy, so I'm going to not do that one. So I'm going to do quadratic formula. All right, so we get x equals -b plus or minus the square root of b squared minus 4ac. We have minus b becomes minus -1, becomes a positive 1. I'm not going to redo this. We already found b squared minus 4ac. We said it was 13. And then if we do 2a, we get 2 times 3 is 6. And we're done. All right, last one. We have 3x squared minus 6x plus 7. We'll start by finding our discriminant. We have b squared minus 4ac. We have a is 3, b is -6, and c is 7. And so when we plug this in, we get -6 squared minus 4 times 3 times 7. We get 36 minus 84. And if we subtract this, we get, I believe, -48. Because it is negative, this means no real solutions. And again, for this section, we're not going to continue. We don't solve. Okay, so there is looking at some equations. Now let's go ahead and continue looking at a couple other things. Okay, this should be review. We talk about finding intercepts of quadratic functions. For the y-intercept, or sometimes called the vertical intercept, remember that we plug in 0 for x and we simplify. For x-intercepts, or sometimes referred to as horizontal intercepts, we want to plug in 0 for y, and we want to solve for x using either factoring or quadratic formula. All right, let's go ahead and look at some examples, and we want to just kind of play around with this discriminant and intercepts and that sort of thing, okay? Okay, so let's look at what we're going to do. The first thing we want to do is we want to find the coordinates of all intercepts. We want to be able to identify the sign of the leading coefficient, and even though the equations are given to you, we want to verify it graphically. And then we want to use the graph to determine if the discriminant is positive, negative, or 0. All right, let's start with example A. Okay, the first one we have is y-intercept. I always start with y-intercept. It's the easiest thing to find on these. And so my y-intercept, again, sometimes called the vertical intercept, is going to be 0, -5. Remember that we do want these in point form. We also want to find our x-intercepts. And here, because they are not nice on my graph, we should go ahead and try to find these algebraically. And so we are going to go ahead and plug in 0 for y. And we're going to try to factor this. So let's see what we come up with. Okay, 6x squared, I think that's going to be 3x and 2x. I'm kind of guessing that just because when I look at my graph here, I see kind of something that looks halfway between. This is not quite halfway in between, but you know, a third of the way, that looks pretty good. And so we want denominators of 2 and 3. Those are going to be my coefficients. The second thing is we want to figure out, okay, how does 5 break down? I'm going to go with 5 and 1, and I'm going to place them here because we do have a negative 5, which means we need to subtract to 13. That means I need my larger number to be bigger than 13, and in order to do that, I want to multiply 3 times 5. This is going to be positive because my 15 is larger than 2, and then we have our minus in the other one. All right. If we set each factor equal to 0, we can add 1 to both sides. We can divide by 3, and we get 1/3. And for my other one, if we set it equal to 0, we can subtract 5 from both sides, and we can divide by 2. We do want x-intercepts in point form, and so we're going to go 1/3, comma 0, and we're going to go -5/2, comma 0. And that looks to be about right. Positive 1/3. Our other one we have is -2.5. And that's what we've got. Okay, our leading coefficient. Remember that our leading coefficient just tells us if this opens up or down. Because this opens up, my leading coefficient is positive. And when we look at our equation, yeah, that's what we have. The last thing that we want is we want to know about the discriminant. And so my discriminant is positive because we have 2 x-intercepts. All right, that is the first one. All right, let's come down to the second one. Okay, the second one, we really can't see what the y-intercept is, but there is a y-intercept. And so for this, remember to find y-intercept, we want to plug in 0 for x. And so if we plug in 0 for x, we get 9 times 0 squared, which is 0, plus 30 times 0, plus 25. My x terms cancel, and I am left with y equals 25. So my y-intercept is 0, 25. All right, x-intercepts. Note here that we have one x-intercept. It intersects, it touches the x-axis just once. And so what that means is that we do have one x-intercept. And when you have one x-intercept, this should be factorable. This should, not only should it be factorable, but our factor should be exactly the same. And so in order to do that, 9x squared is going to be 3x and 3x. 25 is going to be 5 and 5. And because we have a positive 30, we should have plus plus. We can go ahead and work with just one of the factors. We don't have to do this twice. If we set it equal to 0, I can subtract 5 and divide by 3, and we get x equals negative 5/3. In point form, this is negative 5/3, comma, 0. All right, we also want leading coefficient. Leading coefficient is positive because it opens up. And we know that our discriminant is equal to 0 because we have one x-intercept. For the discriminant, you can go ahead and check it using the formula for both of these, but this is what we can go ahead and see. All right. Let's look at one more. Let's look at example C and figure out what we've got here. Okay, we're going to start with intercepts. I can see my y-intercept here. And so my y-intercept, it looks like it's about halfway there. So I'm going to say 0, comma, negative 2. And if we look at our equation, remember it's this constant term on the end, and that's what it is. The next thing that we want is we want x-intercepts. This is going to be factorable, and the main reason I know it's factorable is I do see that we have a nice x-intercept here. And if you have at least one nice x-intercept for quadratics, then, well, the other one has to be nice too. And so if we go ahead and factor this, the first thing that I'm going to do is I don't like my leading number being negative. And so I'm going to divide everything by negative 1. And we do it to the left side as well. And when we do this, we get, stop that, 0 equals 7x squared plus 15x plus 2. All right, when we go ahead and factor this, I know that 2 is 1 and 2. And then I also know 7x squared is 1 and 7. And because we have this x-intercept of negative 2, I know that I don't want my 7 with the 2. We're going to play around with these a lot more over the course of the semester. But this is basically how I want it to factor. We do have same signs, so I want to add to 15. I want my 2 and my 7 to be multiplied together. That gets me to 14. That's about as close as I can get. And so this is our correct factoring. If we go ahead and set this equal to 0, we can subtract 2 from both sides, and we get x equals negative 2. On the other one, we can subtract 1 from both sides and divide by 7. We want to point or write our x-intercept as negative 2, 0, and we get negative 1 over 7, 0. Okay, leading coefficient. Our leading coefficient is negative because our graph opens down. And when we look at our equation, that is what we see there. And the last thing that we have is our discriminant is positive because we do have two x-intercepts. A lot of this class is going to be based on kind of looking at equations and trying to figure out some of the basic features. And remember, basic features is always going to be intercepts, direction, and how many intercepts. And so that's going to be a big thing that we focus on. And we will be extending this in the next module into polynomials in general, meaning cubics and quartics and other ones. And so we will be playing around with these concepts more as we progress through the class. All right, that finishes this section. In the next section, remember that throughout this section, I've been talking about we can't take square roots of negatives. In the next section, we are going to be taking square roots of negatives and playing around with that. All right, we're done with this one. And I'll see you again soon.